Bismillahirrahmanirrahim. Assalamu alaikum to my all viewers. I'm Yasser Abbas. Please subscribe my channel for future videos. And if you have any issues in your data analysis part, you may contact me to get services for your data analysis. Today I am going to explain about the multiple mediation analysis. In this analysis I am going to do mediation analysis with the two mediator and two dependent variables. As you from previous video, this is my code based model on which I am doing work and making videos to elaborate the all possible paths analysis that are required in your research. So let's go to the SmartPLS 4 version and again I here make a duplicate file of my base model uh, on which I have to perform a multiple mediation. I have to save it mediation for the sake of two mediator and two TVs. Let's save this file, a copy of my base model, and then we will work on it. Here the model will be shown to you on which we have to do multiple mediation analysis. In this analysis you can see that this is a complete model and we have to break into different parts for our thesis requirement. So I have to delete moderator here, and the number one mediator is also doing. Now basically here we have a two mediator and two DV, but prior to do a mediation analysis in this setup I will do by taking a single mediator with two dependent variables. Then at the last I will show you how we will add the second mediator and see the analysis. Basically when we will work on a single mediator with two dependent variable, it will replicate the same thing with the second mediator. So prior we have to do with a single mediator with the two dependent variable to completely understand it. So let me delete it here, my second mediator. Now this is a simple model with a single mediator with a two dependent variable. I actually want to show you that how we will analyze the different paths of this for single mediator, and then I will show you that how it will affect the when we will take the second mediator. So here you will see that I have taken single independent variable with the two dependent variable and single mediator. Now actually here you can see that there are basically here are basically how many paths are there. This path as in my previous video I told you that the IV to DV IV to DV is the direct path, and the direct path here is IV to DV is this is the direct path for IV to DV1, and the second one is also is the direct path for IV to DV2. Now the indirect paths are the indirect paths is the this one. If I name it A, and IV to mediator A is the A and mediator to DVA is the B. Now the A and B, the indirect path one is A into B, and for indirect path the indirect path B is the this one is C, and second indirect path is the A into C. Now in this case we are concerned with the indirect paths for the mediation analysis. If these paths are significant, then we will say that there is a mediation between the between these variables. if a into b path is significant, we will say that the mediators this mediator actually mediate the relation between iv and dv1, our first derivative. And if second path is significant, we will also say that the this mediator mediate the relationship between iv to dvb. But if any of this becomes insignificant, then we will say that there is a no mediation between. For example, if the second path a into c becomes insignificant, then we will say that there is a no mediation effect between the iv and dvb. So we have to run this model and analyze the paths and their significance. Okay, let me directly we are going to calculate or its bootstrapping instead of using PLS SEM algorithm simple, as my variables are the latent variable. So I will use here the consistent PLS SEM bootstrapping. The output of the bootstrapping will open here, and other thing remain, I think, should same for bootstrapping. It is for 5000 subsamples, it's enough for bootstrapping PLS setup, in which we will change it to into path analysis and data. There is no change in the data analysis, just we will click on the start calculation option. In bootstrapping, you people know that it takes some time to execute the analysis. Basically, it takes different samples and compute the score for each variable. So and also calculate the probability values of the coefficient. So it will take some time to execute. uh, so you have to hold on for a moment. The analysis is almost done, and the results will be shown here. I have not cleared this screen, so I can show you that how it affect the actual my results in here. I am going to change here construct in. We cannot change the value of r square cronbach alpha here in this model for a construct, because you will see only these value when you will run either it in a simple PLS algorithm. And for outer model is the basically outer weights and outer loadings. Here it is, its p value is shown. So we can change into t values, outer loading with p values and t values, and I am simply click on the going to set into t values. T values must be greater than 1.96 R2. If the values are greater than 2, then these all items had a significant loadings, or its loadings are greater than the 0.70. You can see it here also. For inner model, as we are concerned with the inner model, and inner model, here the p values are shown, and p values shows me that the path are significant. For further confirmation, I will click here and show you path coefficient with their p values. Now the let me zoom in it. Working with the SmartPLS in this setting, it sometimes change the settings. So you can now see here, this is the direct path. Now it's showing the direct path, and you can see easily that the all paths are significant in my case. In some other one, you are working with a different model with a different data, you will get definitely different answer. But I want to show you that how we will perform a mediation analysis in this setting, and what the result we acquired here. So in this case, you can see that the my both parts, both indirect paths are significant, and if the paths are significant, we can say that the this mediator mediate the relationship between the two variables. In graphical view, it gives us the output that either these are significant or insignificant. You can also judge from the result that if the path A is significant, mean IV's impact on mediator is significant, and then mediator impact on dependent variables are also significant, then this will also be the indirect path will also be significant. If any of the paths here become insignificant, then you can say, or you will see that the indirect path will also become insignificant. Its p-value is greater than 0.05, then here you will see that there will be no mediation between these variables. So I will show that either indirect path are significant or not. For indirect path, you can see what we how we calculate the indirect path. Basically it multiplied 0.473 into 0.321 and calculate the score and check its significance, that either its significance is it is significant or not. Let's me just suppose value for 3 is at 12, it maybe have value about 0.135 or so, like that, 1 to 5 are is I will show you here. We go to the output for the path coefficients. This was the graphical view of the our results, which is shown here, and this is the path coefficients that we have calculated here. This path coefficient are the basically results of the all models effect, like IV2, DV1, DV2, mediator and mediator. These results you have to show in your on your analysis part or in your thesis, and first you have to describe or explain these results. Then you will move to the specific indirect path. Specific indirect path are the basically the paths which I have explained to you, that how it takes the indirect path. You can see also here IV2 mediator C to DVA first derivative which I have taken, and I have told you that its value will be equal to 0.123 or so. Its value is when we calculate it, its actual value will be 0.152, and it is a significant. The second path is the its value is minus 0.220 is significant. And if these specific indirect paths are significant, then we will say that here the mediator mediates the relation between the two dependent variables, with one independent variable and with the two dependent variable. So here the mediation exists between the in this case for this model. When if you want to check overall effect of this total indirect effect, and for total indirect effect you will also see the same result shown here, and the total effects are significant. You can also find the also say that the overall effect was significant, and there is a mediation between the given setting or given variables. Now let me you can save this report, the result output here. Just click on the save icon here, and it will automatically rename it, and with a given date you will save the report here. And when you give back to the main window, let me save this model here also. When you will be back on the same model, your reports will be shown here with the blue icon, like multiple mediation 2 with DV is given date is also with a given date, and you can directly again open the report from here. Now I will move to again with this model multiple mediation, and incorporate the second mediator here. The second mediator was my mediator B, and I think I have taken its 5 components here, and just drag it here and rename as a mediator B. I have to connect this. Now I have to change certain setting of the model so it will look easier to you and understand. We have to connect this mediator with the other variables IV to DV, DV to mediator A, and mediator B. So now there are actually 4 indirect paths, and I think you will easily understand this. There are now 4 indirect paths which we have to calculate to check out the mediation effect. The fourth in paths are the let me show explain here. Let me explain it here. The first path is the you can see the IV to DVA is the direct path. Again, this is a direct path. IV to DVB is a direct path, and indirect paths now will be, if I rename it here, let's suppose this is the A, and for green I will show the effect of IV to mediator C to DV A and B. Let's suppose this is a B and this is a C. These paths are the for first mediator C, A into B and A into C. And for other I will explain into different colors. Let's suppose this is a here IV to mediator B is the D, and its indirect path on A will be let rename it a E, and on DVB is the F. Now for mediator D, mediator sorry B, second mediator, its indirect path will be D into E, D into A and D into F. These four direct paths, we have to find out the significance of these four direct paths, and if all the paths are significant, then we will say there is a mediation between the given mediators. If any of one is insignificant, we will say that there is a no mediation effect between the given variables. For example, if I say that the D into F path is insignificant, then this means that the IV to mediator B to DVB, there is a no significant mediation effect of mediator B between IV and DVB. And other, if all other paths are significant, we will say that there is a mediation effect between the given variables. Let's simply go to the calculate option again and execute the bootstrapping option to show you that how the indirect path will be give us results. The setting will remain the same. PLS setup should be on a path analysis. Data is already the same. We are using single data set, so I click on the start calculation option and the bootstrapping will start running. At the time will shown here that how much it will take time to find out the results. The bootstrapping or results are basically used to calculate the probability value, because when we run on simple PLS SEM algorithm, this actually gives us the beta weights or the regression weights, not give the probability values. So I'm sorry. So we have to calculate the all beta values with their probability values to check the significance of our model. Like here, I have told you that you can see here I have made. Let me zoom in and zoom in, and you can see here again you can move the arrows front or back according to the data. If you remain confused that is this variable is with this or not, you can just move the icon here and you will see the movement of your coefficient value. If the coefficient value is moving with this, then it's understood that this value is with it. Sometimes it will be shown here, and you can be confused that either this value is with the mediator B to DVA or other one. If it's moving with the this cursor, then you will say that this value is with this variable and change accordingly to your requirement. So this is the overview of the graphical results, and I have already set it in a different into t values. Auto loadings have shown in the t values, and for path coefficient also with the p values. So directly we go to the output path coefficient analysis, and here you can see that IV into DVB effect is the insignificant and all other parts are significant. Now this path insignificance are also very interesting results here. Shows for our like when we talk about the full mediation or partial mediation, full or partial mediation, and I will show you that is it partial or full mediation. You have to remember that this path is the IV to second derivative dVB. Now these are the direct effects of the all model variables, and we are interested for mediation in a specific indirect path on the first hand. And here is the basically four indirect paths which I have told you that IV to mediator C to TVB is the first path. It is also significant. Second path is also significant, and again then second mediator B and with mediator B with DVA and DVB is also significant. The four paths are significant, so this confirms that there is a presence of effect mediation effect of the both mediators in this case. So let me again, you can check it here. You are just concerned here for these results. The first one is the main results, second is your specific indirect effect for mediation analysis. You can also check the total effect. Total effect will be same, the is the combination of the direct and indirect path effects. So here is the total indirect effect and total indirect effect. What is the difference between the specific indirect effects and total indirect effect? If you see that the in specific indirect path we have a four paths, sorry. The four paths mean that the IV to mediator C to DV A and B. Similarly, IV to mediator B to DV A and B. These are the four paths. When we talk about the total indirect effect, this shows the IV's effect on DVA, which using one mediator like mediator 1, and this IV to DVB is the IV to DVA is the total effect of mediator A and mediator B. For both, it takes the total effect on the dependent variable A, and similarly IV with the two mediator, total effect on dependent variable B with the mediator is the second path. If both paths are significant, it shows that the both mediator have a significant on both the dependent variables. So in this way you can explain this in your analysis part. One thing I have to show you that this path was become insignificant here. In this path become insignificant. uh, also it is very close to 0.05, but we will consider it as a insignificant. This insignificant path shows that the IV's impact direct impact on DV becomes insignificant. In prior model you will notice that the IV's impact on DV was significant, but after incorporating, if the mediation when we included the mediator, this path become insignificant. We will say in this case this path is IV to DVB, then we will say there is a full mediation effect of mediator C and B for the relationship of IV and DVB. But for its direct path for DVA is still significant, then there will be a partial mediation effect of mediator B and mediator C on DVA. So in this way we can explain the multiple mediation, and this is also called a partial mediation effect. This is also called your partial mediation effect, and this is partial mean parallel mediation effect, or you can say it is a multiple mediation. I think I have explained in detail. You can now do analysis on your end. Thank you very much.